All right, so in this lesson, we are going to focus on natural logarithms, and the rules that apply to our common logarithms, but we're going to simplify these expressions and we're going to solve exponential equations by using the natural logarithm. Things we understand: natural base, exponential function, and natural logarithm. So just in the beginning here, exponential function with base e, written as y equals e to the x power, is called the natural base exponential function. Thinking about what is the value of e, and it's that irrational number here, it's Euler's number. So as we're using that, just looking at my diagram here, hopefully you can see that the natural base, the exponential function and the natural log are inverse operations, as they seem to be reflective over this, magical y equals x, which shows us our inverse relationship graphically. So we're going to be able to, understand and use this the same fashion that we were using common logs for base 10. So here, thinking about how do we, what is going on here. So when I have the natural log of 6, and of course that is on your graphing calculator. This is on your graphing calculator, right there below log, you have your natural log, ln. And that is basically understood that when we have a log base e, that is my natural log. So rewriting that, I could write it in log base e of 6 is the natural log of 6. And then, of course, converting it into the exponential form, that e raised to some exponent is going to be equal to 6. So e raised to some exponent, because remember, the log is nothing but an exponent. So just being able to do this reordering process, going from exponential to logarithmic and moving back and forth. Again, it's just a log base e, so we should be able to manipulate those formulas or functions in the same fashion that we do regular exponentials and logs. So here, as we look here, the natural, or e raised to the x power, is going to be the same thing. Remember, log of base e raised to some exponent is equal to 14. That's how we reorder that. And then, of course, log base e is nothing more than the natural log. Same thing here, that the log of base e is the log e raised to the seventh power equals x is the same thing as log base e of x is equal to 7. So again, being able to reorder that, knowing that log base e is nothing more than my natural e. So there we go. Looking at these, let's see, how could I reorder these? So this is my base. So I would have the log base e of 4x is equal to 3, because e raised to some power is equal to 4x. Versus over here, I would have, again, the log base e of 3 is equal to 4x. So e raised to the 4x power is equal to 3, and of course, then the log base e is nothing more than the natural log of 4x is equal to 3, or the natural log of 3 is equal to 4x. Again, being able to understand natural log is nothing more than log base e, and then manipulating it. Here now, writing the equivalent exponentials, again, so this is simply log base e. So I have the log base e of 9 is equal to x, so e raised to some exponent is going to be equal to 9. Being able to manipulate these to go from log to exponential. Now here we have just, great, the natural log of x is approximately equal to 1.7347. So reordering that, we know that is the log base e of x is approximately equal to 1.7347. So again, the e raised to some exponent is equal to x. And that may be hard to see here, but this is e raised to the exponent of 17347 is approximately equal to x. Okay, and then the same thing here. So again, this is log base e of 3x is equal to 4. So my base remains e raised to the exponent is equal to 3x. And again, I have over here the log base e of 4 is equal to 3x. So I know that my base of e raised to the exponent 3x is equal to 4. So being able to manipulate those functions. Now, converting into a simplifying a logarithmic expression. Thinking about exponents and properties. Let me see here, where do they talk about this more? But understanding that when you deal with exponents, when we have exponents divided, common bases, x squared divided by x to the first. That is the same thing as x2 minus 1, which is just x to the first. So when we are dividing like bases, we subtract. And that's what we are seeing here, that relationship. So thinking of logarithms as exponents, we have exponents, being subtracted, or logarithms being subtracted, which is the same thing as division. We have logarithms being added, which is the same thing as multiplication for our exponents. So that is how we understand those properties. So I have 1/3 natural log of 8 minus the natural log of 3 plus the natural log of 9. So that would, again, reversing that power rule, we have the natural log of 8 to the 1/3 power minus the natural log of 3 plus the natural log of 9. And so this simplifies to the natural log of 2 minus the natural log of 3 plus the natural log of 6, which, again, the natural log of 2 minus 3 is going to be division. So the natural log of 2/3 plus the natural log of 9, which is really plus is indicating multiplication. So the natural log of 2 divided by 3 times 9 is going to be the natural log of 6. So there you go. Being able to do this kind of reordering and understanding the properties makes things a lot easier for us. Let's see here. So yes, the calculator will come up with that and verify your solution. If you were to put that into the calculator properly, 1/3 times the natural log of 8 minus the natural log of 3 plus the natural log of 9 is going to give me the same decimal or the same value as just saying the natural log of 6. So they're showing that we did the proper manipulation. So I would take a second, use your exponent rules, and see if you can do this, and then check your answers. Okay, so again, just sort of manipulating it one step at a time. The natural log of 7 minus 1/3 the natural log of 27 plus the natural log of 6. I simplified this power rule, right? It would be the natural log of 27 to the 1/3 power. I know that 27 to the 1/3 power is going to be 3. So the natural log of 7 minus the natural log of 3 plus the natural log of 6. This would indicate division. So I have the natural log of 7 divided by 3 plus natural log of 6. Plus would indicate multiplication. So I have the natural log of 7/3 times 6 over 1, or the natural log of 42 over 3, which is also equal to the natural log of 14. So that is being able to reorder into a single logarithmic expression. Okay. Now, solving exponential equations by using the natural log. When we were doing common logs, we would raise both of our sides of our equations, right? We would take that side to the exponent, 10 to the exponent of. Well, now what we're going to do is we're going to use e. So understanding some of these properties, that e raised to the natural log of x is simply x. So the natural log of e raised to the x power is x. So these two things are applicable, okay? And I think too, if you think about it too, this would have been rewritten right here as the log of base e to the x power, which we know is x. This over here would be e raised to the log base e of x, which we understand to be x. So just that reordering and simplifying those expressions. So these properties right here, we will continue to use moving forward. So here, gosh, I wonder what that says right there, but We'll get to it. Exponential equations with base e, maybe solving. Okay, if not, we'll figure it out. So I have this equation and I want to round to the nearest 10 thousandths. Great, so I'm going to solve it. First thing I want to do is I want to take this and I want to isolate my expression with the variable. So I would go ahead and I think I would subtract 8 from both sides because that would be the easiest thing to do. So subtracting 8 from both sides, this becomes 0. This becomes a negative 14 minus 8, so negative 22. And then now that I still got this number out here, so I'm trying to isolate this expression, so I'm going to divide both sides by 2. And I get e raised to the x plus 3 is equal to 11. Now, again, now that I have that, I can go ahead and raise both sides to the natural log, and then that will, natural log of e will simply become the exponent. So I am going to have, and let's see, I'm going to back up here and just think about what's going on right here real quick, or let's just accept this. The natural log of e is going to be the exponent, so I have x plus 3 is equal to the natural log of 11. I'm going to, they simplified this to the decimal, and I could do that later on. I could just go ahead and divide both sides, or subtract 3 from both sides, and x is equal to, right here, x is equal to the natural log of 11 minus 3, which if I put that into the calculator, it would come to this value. Okay, so I can just do that all at one time. I don't need to convert it to a decimal ahead of time. Something to think about, though, going back to this expression. If you think of that in the power rule, okay, the natural log of e to the x plus 3 is the same thing as x plus 3 times the natural log of e. And just remember, the natural log of e is the log base e of e. And then we know that this is equivalent to 1. So what we have there is that's how we come across and realize that that is going to be just simply x plus 3. So remembering those properties and being able to utilize them. And then so as we look at, and that's a little bit all over the place, but just thinking about as we process, what are the things that we know and remember about our properties. Here, solving this equation, go ahead and take a moment, try to do it. Look and see that, hey, it looks like we have everything in the exponent there, so there's not a lot to add and subtract, but I will be dividing. And I will give you a moment to go ahead and do that, and then come back and check your answer. Okay, so as we go on with this, what I did was I realized that, hey, I've got a bunch of exponent going on here. So I went ahead and divided by my coefficient on both sides, and then I have e to the 0.25x plus 3 exponent equals, simplified this to 13 over 3. So then now that I have e, I raise both sides to the natural log, and then we know that the natural log of e is 1, so I end up with 0.25x plus 3 is equal to, this came to 1.4663 as a decimal. I subtract 3 from both sides, and I end up with 0.25x is equal to negative 1.5337, dividing both sides by my coefficient there, and I end up with x is approximately negative 6.1347. And that is just using my property to solve. Again, the same properties that we were using before, now we're just raising sides to the natural log. So here as I look at this next example, the natural log, how to solve that natural log equation. Again, I have this 1/6 natural log of 5x equals 2. What can I do here? I can multiply both sides by 6 to get rid of my fraction. So the natural log of 5x is equal to 12. Now, the inverse of the natural log would be raising both sides to e. So if I raise e, I have e raised to the natural log of 5x, which simplifies to 5x. Raising the other side is e to the 12th. Now I can go ahead and divide both sides by 5, and I get x by itself, and x turns out to be equal to approximately 532,550.9583. So that is using logarithms or natural logarithms to solve equations and the value of e. But really that's beyond the scope of what we are wanting to understand now. We are wanting to understand how to utilize the natural log, how to utilize our common logs, how to work with the properties and solve equations. So we will move on, and good luck. And as you can see, I have crossed off some stuff here that we values, equations, we're not going to be utilizing this course. But just understanding that it is possible to algorithmic thing, use your calculator to come up with some of these